Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, in this lecture, I want to discuss a very interesting topic of a differential equation that is known as a simultaneous linear differential equations. Simultaneous means more than one variables are occurring in a differential equation simultaneously. So, here we can say that the given differential equation is known as a simultaneous linear differential equation. So, types of the simultaneous linear differential equation is given as follows. So, here we are giving an example of simultaneous linear differential equation. So, in this simultaneous linear differential equation, minimum there are two equations. If two variables are there, then two equation is must should be present in our question. If there is only single linear differential equation is given, then we cannot find the solution of the simultaneous linear differential equation, because there are two variables occur simultaneously. Then there is very compulsory should be two linear differential equation. Okay, with the help of equation 1 and 2, we can find the value of two dependent variables. So here in our example, we see that dx over dt. Here x is dependent variable. X is dependent variable. Dependent variable, which is dependent on t. Means x is some function of t here. X is dependent on t and plus 4y equal to t. T is independent variable. X is dependent variable here. X is some function of t here. X is dependent variable on t and y is also dependent variable. Now, t is here independent variable. In our question, t is independent variable, but x is dependent on t. X is dependent variable. X is dependent on t, but t is independent variable. Another variable is in other equation. So equation second, we see that dy over dt. Here y is dependent variable and t is independent variable, because here differentiation of y with respect to t. So y is dependent variable and t is independent variable. Y is dependent on t in second equation. Here y, here is x. Here is x, 2x. So here is 2x. X is dependent variable here. Here is y. In equation second, here is x. X is dependent variable. Y is dependent variable. In equation first, y is dependent variable and x is dependent variable. In both equation 1 and 2, t is independent variable. In both equation, two variables are occurs here, x and y, and both variables are dependent variable, and both variable x and y dependent on t. So here, solving equation 1 and 2, we find out the value of x in function of t and also value of y in function of t. So here both variable occurs. So we can say this given differential equation 1 and 2 is known as a simultaneous linear differential equation. Okay. Here d over dt differential with respect to t is equal to d, capital D. We considering in our question differentiating with respect to t is capital D here. D is operator, differentiation operator. D is known as a differentiation operator with respect to t. Here t is independent variable and x and y independent variable. X and y are dependent variable on t. So in our equation 1 and 2 involve two variable. Both variable are dependent variable, dependent on t, and t is independent variable. So after solving equation 1 and 2, we find the value of x and y. X is also value in t and value of y is also in t. But here differentiation with respect to t, d over dt represented by capital D. D is differentiation operator with respect to t. Definition of simultaneous linear differential equations. How we can define a simultaneous linear differential equations? So definition: in a differential equation, there are more than one dependent variables. In any differential equation, we see that there are more than one dependent variables and only one independent variable. What dependent variables are dependent on a single independent variable in all question. Then we can say that given question is known as a simultaneous linear differential equation. Okay. In given type of equation 1, here given equation 1, x and y are two dependent variables. Here we have given last example. Here in these two equation 1 and equation this 2, in both equations we see that this is the type of equation 1. X and y are two dependent variables and only one independent variable t. So here x is the some function of t and y is also some function of t. And the given equation 1 is known as a 1 and 2 are known as a simultaneous linear differential equation. Problem 1. Here we want to discuss one problem based on simultaneous linear differential equation is given as below. This problem is very easy problem and the solution of this problem is very interesting. We can solve this problem simultaneous linear differential equation very easily. So here I want to discuss the process to solve simultaneous linear differential equation in detail. So here first equation 1 is given here. Dx over dt plus 5x minus y equal to 0. This is equation 1. Here is 5x. This is equation 1. B. This is 5x and minus y equal to 0. This is equation 1. In one equation we see that dx over dt, here differentiation of x with respect to t. So x is dependent variable and t is independent variable. So x is dependent on t plus 5x and minus y equal to 0. Second equation dy over dt, here differentiation of y with respect to t. Y is dependent on t, t is independent here. Y is some function of t plus 2x plus y equal to 0. This equation 2, where initial conditions are given that in our question some initial conditions are given here. So what is the application of initial condition? If in our question initial conditions are given, then first of all, we find the complete solution of simultaneous linear equation 1 and 2. After solving, we find the value of x and y in some function t. After finding value x and y, then in both solution, we apply these initial conditions. After applying these initial conditions, we find out the value of constant. Then again putting the value of constant in our solution, x and y, then we find complete solution. After giving initial condition, then in our solution, there will be no constant. Constant are find with the help of initial condition. So here initial conditions are given. Here we discuss initial condition. X equal to y equal to 0. If t is 0, if the value of independent variable here 0, then x and y both variable are 0. What I meaning? X means xt. T is 0 here means this is 0. Putting t 0 here means x 0 is 0. Here also yt is 0. What t is given here? 0 means y0 is 0. So this is the explanation of initial condition. We can apply this initial condition in our question. So first of all, we find out the solution of given question in complete form. After complete form, we apply these initial conditions. Solution: dx over dt plus 5x minus 2y equal to 0. This is equation 1. Equation 2, dy over dt plus 2x plus y equal to 0. Equation 2. So here two equations is compulsory to be in our question. If there is only single equation, then we cannot find the value of x and y. If two equations are given, then we can find value of x and y, because in each equation there are two dependent variables, x and y. So with the help of 1 and 2 equation, we can find the value of two dependent variable x and y. So in our problem, we see that in LHS, in left hand side, we see that of problem 1, x is the sum function of t, because x is differentiate with respect to t, and also y is some function of t, y is also differentiate with respect to t. So here x and y are dependent variable, and x and y are both are dependent on t. But here t is independent variable. And in RHS, we see that RHS, right hand side, some function of t, that is phi t. In right hand side, there should be some function of t. But here, in this question, phi t is 0. Phi t is 0. Right hand side is, there is 0 value. So in right hand side, the function of t is 0 here. Here, both dependent variables occurs here. In our equation 1 and 2, both variables x and y involved in each equation simultaneously, dependent on t, which are dependent on t. X and y both variable are dependent on t. We will discuss here about the procedure, how to find the solution, how to solve simultaneous linear differential equation. In detail, we want to discuss the procedure to solve simultaneous linear differential equation in detail. So here, dx over dt, I am writing again question here one time. Dx over dt plus 5x minus 2y equal to 0. This equation 1 is given in our question paper. Next, dy over dt plus 2x plus y equal to 0. This equation 2, which is also given in our question. So combination of equation and 1 and 2, then we get question 1. In our question 1, both equations are present here. I am saying that here, if there is only single equation, then we cannot solve the equation. We cannot find the value of x and y. We cannot find the value of dependent variable x and y. If two equations are given there, then we can find the value of x and y. So in our this question, there are two equations, equation 1 and equation 2. And here d over dt is capital D, differentiation of function with respect to t. So this is the derivative with respect to t known as a capital D. This is derivative. Okay. Operator. This is known as a differentiation operator, capital D. Capital D is d over dt here. T is independent variable. Then equation 1 and 2 can be written in the following form. So I am writing equation 1. Equation 1 means here in our question is dx over dt. So dx over dt, what is dx over dt? That is dx. D means d over dx. So that is dx. So I am writing, and dy over dt is capital dy. So both value putting in equation 1 and 2. Then this equation 1 and 2 convert in equation 3 and 4. So I am writing here dx over dt is dx plus 5x is as it is minus 2y equal to 0. This is equation 3. First equation convert in equation 3. And similarly dy over dt is dy and plus 2x plus y equal to 0. Equation 2 convert in equation 4 after putting operator d in place of d over dt. In place of d over dt, putting operator d. Then we can write equation 1 and 2 in the form of equation 3 and 4. After taking x and y common, now in equation 1, we taking x common to right hand side. Because x is a differentiable function, so x taking right hand side common. Here x is not taking, never left hand side. If we taking x left hand side common, then question 100% wrong. Because here is operator is using in our question, then we taking common always right hand side. So here this is in equation 2, 3. There x is common here. Here x is common, taking right hand side common. Then d plus 5x and minus 2y equal to 3. Here is y. I am writing dy plus y. So y is common here. In this term and this term, y is common. So d plus 1y plus 2x equal to 0. So we can find here d plus 5x minus 2y equal to 0. Equation 5. Here plus 2x. I am writing 2x. X here. In first equation, first term is x. In second equation also first term is x. So I am writing here 2x. And next, taking common here, dy plus y. This dy and plus this y. So by taking common right hand side. So here d plus 1y equal to 0. Okay. So this is after taking common x and y. Then we get equation 5 and 6. In equation 5 and 6, making x variable equal. Similarly, this equation x plus y equal to 4 and x minus y equal to 6. This type of equation this. Here x equal here. Y is equal here. Okay. So sign is same opposite this. After adding this equation adding here. After adding y is cancel. Then 2x equal to 10 and x equal to 5. So similarly this formula apply in equation 5 and 6. Any one term should be equal here. So now in equation 5 and 6, making x variable equal. So here apply. This x should be equal. Apply eliminating method. Multiplying by 2 in equation 5. In this equation, denominator coefficient of x multiply here. And in each term LHS and RHS. And operating by d plus 5. In first equation, equation 5, there is d plus 5. D plus 5 operating in equation 6. So operating by d plus 5 in equation 6. In each term LHS and RHS. Left hand side and right hand side. Both side operating by d plus 5 in equation 6. And multiply 2 in equation 5. What will be happen? After doing this, means x variable will be same here. After 2 multiply in this term and d plus 5 multiply in second in equation 6. Then x variable is equal. Y is not equal, but x is equal. So we see here 2 multiply here d plus 5x minus 2y equal to 0. 2 number never operator. Number is only in multiply. What differentiation is operator. So differentiation never multiply. That is operate the equation. So here 2 multiply here each term in this equation 7. This is we get 7 equation. And d plus 5 operating equation this 6, then we get 8 equation 8. So d plus 5 in this equation 6 operating d plus 5 total in equation 6. This is equation 6. This 6 operating d plus 5. This equation 5 multiply by 2. Then we get first term equal. So now here we see that in equation 7 and equation 8. First term of x is equal. Then apply formula. Equation 7 minus equation 8. From equation 7 minus equation 8. So here this equation 7, 2d plus 5x minus 4y. Because where how we get here 4? Because we multiply 2 in each term in last equation. This 2 d plus 5x, 2 to 4 equal to 0. Here d plus 5 operating d plus 5. So we get this equation 2d plus 5x plus d plus 5 and d plus 1y equal to 0. This equation 8. Now this equation 7, this equation 8. Subtracting from 7 to 8. So here changing minus sign. Sign is changing here. Here sign is changing. After subtracting, then we change the sign. And this term is cancelled. This term is cancelled. These terms are remaining term. There is only y. In this term and in this term. There is only y. X is eliminate. From equation 1 and 2, we eliminate the variable x. There is only y variable is there. So now this second term writing here minus d plus 5 and d plus 1. Y minus 4y equal to 0. Multiply by minus 1 in each term in equation 9. This is equation 9. This term is minus sign. This term is minus sign. So here making these minus sign in positive sign. So we multiply minus 1 in each term. So multiply by minus 1 in each term in equation 9. Okay. So we get here d plus 5, d plus 1y plus 4y equal to 0. This equation 10. Next, simplifying equation 10, then we get. Simplifying means after multiply. After operating here. So here in equation 10, multiply this bracket to this. So this is d into d. D into d means d square. Second derivative, second time differentiation. And d into 1, that is d. And 5 into d, that is 5d. And 5 into 1, that is 5. Y and 4y equal to 0. So after solving, y is common here. y is common to the right hand side, not left hand side, because y is differentiable here with respect to t. Y is dependent variable here. So y always goes to right hand side common. Simplifying equation 10, then we get this d square plus 6t plus 5 plus 4y equal to 0. Y is common to right hand side here. Okay, 5 plus 4 is 9 here. D square plus 6d plus 9y equal to 0. This is equation number 11. Here is only single variable is y. And this equation 11, we discussed this equation 11 in last lecture's detail. So here equation 11 is known as a linear differential equation of second order with constant coefficient. Okay, equation 11, change in linear differential equation of second order with constant coefficient. And this topic we have discussed in last lectures in detail. So here equation 11 can be solved. How we can solve equation 11? So the solution of type of equation 11 we have discussed in last lecture. But I am telling here also, equation 11 can be solved by the method of y is equal to CF plus PI. Complementary function, there are two solutions of the equation 11. First solution is complementary function, second solution is particular integral, which we have discussed in detail in last lectures. What in 11, RHS is 0. We see here in equation 11, 11 means phi t. Phi t is here 0. This is the right hand side. So right hand side is 0 means q0. Phi t means q. Q is 0 here. So q is 0. Then q is 0 here. So particular integral always be 0. If any linear differential equation of second order with constant coefficient, the right hand side value, the value of right hand side means q0 means particular integral is always 0. So here pi of 11 is 0, particular integral. We cannot find particular integral. We find only CF here, complementary function here. Now complete solution of 11. What is complete solution of 11? Y is equal to CF plus pi. Complementary function. This is complementary function and this is particular integral pi. But pi is 0 here because q is 0. In our question 11 differential equation 11, q is 0 means right hand side is 0. Then solution of equation 11 is y is equal to CF only complementary function. So d square plus 6d plus 9y equal to 0. This is equation 11. For finding complementary function of equation 11, putting d equal to m here. D equal to m here in equation 11, putting d equal to m and removing y from equation 11. Removing y. Putting d equal to m in equation 11 and removing y from equation 11. Then we get an auxiliary form of 11. Then we can find auxiliary form, which is in variable m. So that is in variable m. So we get here m square plus 6m plus 9 equal to 0. Putting d equal to m here. D equal to m square plus 6m plus 9. Y removing from our question. So we get here m square plus 6m plus 9 equal to 0. This is equation 12. Equation 12 is an auxiliary form. Auxiliary form. Auxiliary form means putting d equal to m and removing y. Y is the function of t. So y is removing here. An auxiliary form of 11. After factorizing we get. After factorizing of 12 equation. After factorizing. Then we get roots of m. So here is m square plus 6m plus 9 equal to 0. This is a perfect square. M square plus 6m plus 9 equal to 0. This is m ka square plus this is 3 ka square and 2 into m into 3 plus. So this is a square, a ka square plus this 2ab plus b ka square. So here b is 3 and a is m. So m plus 3 ka whole square. This is a plus b ka whole square means this is a is m and 3, m plus 3 ka whole square. This is the factorization. This is perfect square. So the factorization of equation 12, this equation 12, the factor of equation 12, m plus 3 ka whole square equal to 0. Because this is perfect square. Here apply formula a square plus b square plus 2ab. This is a plus b ka whole square. So here is m plus 3 ka whole square. So this is whole square means b write twice in multiply. 2 times b write here multiply. M plus 3 equal to 0. If m plus 3 equal to 0, then m is minus 3. M equal to this 3 goes to this side. So that is minus 3. Again m plus 3 equal to 0. Then m equal to minus 3. Here we see that roots of an auxiliary form. Here we see that roots of an auxiliary form are equal because auxiliary form is a perfect square. Auxiliary form is a perfect square. If any equations which is follow the perfect square, then roots are equal because b square minus 4ac is 0 here. In this question, b square minus 4ac is always 0. So we get here m equal to minus 3 minus 3. M equal to m1 first root and m1 first root. So m1 is minus 3, m1 is minus 3. Formula for CF if roots are equal. Which formula apply here? If roots are equal, then complementary function equal to C1 plus C2. And here t is independent variable. C1 plus C2t e to the power mt. M is a roots. M is a root here. So putting value of m is here minus 3. Putting value of m is minus 3 we have find. So formula is CF is equal to C1 plus C2t e to the power minus 3t. This is equation 14. So here pi is always 0. We have discussed particular integral is 0. So y is equal to CF is complete solution. So this is the complete solution of 11. Y is equal to CF. CF is the complete solution of 11. Now finding value of x. We find here y. Y is some function in t. But now we find out the value of x here with the help of equation 2. What is 2 equation? 2 equation is this. How we can choose here equation 2? So reason is this. Here is only x. Single x is there. We find out the value of x. So in equation 2, there is only single x. There is no derivative form of x. Y is in derivative form. And y is single also. But we cannot find y. We find the value of x. So x is single here. X will be separate here. So I am taking a 2x here, separate left hand side, and equal to other term taking right hand side. So minus dy dt and minus y. Okay, minus y. This equation 15. With the help of 2 equation, we find equation 15. In 15 equations, x variable is separate. And we have the value of y here. We find out the value of y already in equation 14. So now here, now differentiating 14 equation with respect to t, then we get value of dy dt. How we can find here dy dt? Why we are finding here dy dt? Because we putting the value of dy dt in equation 15. 15 is dy dt and y. Y is given in equation 14 and dy dt. After differentiating equation 14, then we get dy dt. So now here differentiating equation 14 with respect to t, then we get dy dt. So what is y? Y equal to c1 plus c2t e to the power minus 3t. This is equation 14. Differentiating with respect to t to equation 14. Then we get here. So dy dt. Here using product formula. In this question using product formula. This is u and this is v. Both are function of t. So we apply here formula u into v. U constant, differential of v. V constant, differential of u. So this formula apply here. Dy dt equal to c1 plus c2t. This is constant. Differential of e to the power minus 3t. So e to the power minus 3t is as it is and minus 3t. Minus 3t is minus 3. Plus e to the power minus 3t is constant. Differential of this bracket c1 plus c2t. T over dt of c1 plus c2t. c1 is constant. D over dt of c1 plus d over dt of c2t. So t is 1. This 0 plus c2 into 1. So this is c2 only. So here writing c2. E to the power minus 3t into c2. So this is equation 16. From equation 15 we have 15 this last equation here, x equal to. So 15 equation. Now from equation 15 we have x dividing by 2 here. In last equation we see that this is 2x equal to minus dy dt minus y. Minus is common. Both are negative here. So minus is common. Dy dt plus y and dividing by this 2. Then we get x. So here x equal to minus 1 by 2 dy dt plus y. This equation 70. Putting value of dy dt and y from equation 16. 16 is this equation. From 16 and 14 we have putting the value of from 16 and 14. What is 16? 16 represented dy dt. Differential of y with respect to t. This is the differentiation of equation 14. And what is 14? 14 is the solution of y. So both value putting in equation 17. Then we get here. So x equal to minus 1 by 2 dy dt plus y. This equation 17. Putting value dy dt from 16. So c1 plus c2t minus 3 e to the power minus 3 plus e to the power minus 3 t. This is c2. And c1 plus c2t. This is y. Now here minus 1 by 2. Taking common here. What is common? This c1 plus c2t. c1 plus c2t is common. And e to the power minus 3t is common. So here minus 3 plus 1. Here is c2. So this is 2 here minus 2. So minus 2 multiply minus sign inside the bracket. So minus minus plus. This is minus 2. This is minus 2. Minus minus plus and plus minus here. So here is 2 c1 plus c2t e to the power minus 3t and minus c2 e to the power minus 3t. This is equation 18. So now multiply by 2. This is 18. 18 is the complete solution of x. We find the value of x here. And y equal to c1 plus c2t e to the power minus 3t. This is the equation 14. Equation 18 is the solution of x. Equation 14 is the solution of y. So equation 18 and 14 is complete solution of one here. Equation 18 and equation 14 complete solution of one. But this is general solution. What is general solution? That solution in which constants are present. That is known as a general solution. If we find out the value of constant and again putting in solution value of constant, then we find without solution without constant. That is known as a singular solution. So in our question, some initial conditions are given. So we want to apply the initial condition in these solutions. So how we can apply condition? Number one, condition is x equal to y equal to 0 when t is 0. This is given in our question. So now x means xt function of xt. This 0, putting t 0. So x0 is 0. Next is yt is 0. T is 0 here given. Y0 is 0. But now here, this is the value of x. Here given value of x means xt. This equal to. So what is xt is from equation 18. I am writing value of x from equation 18. So this 18 is 1 upon 2 in bracket 2 into c1 plus c2t and e to the power minus 3t. E to the power minus 3t. And here is next minus c2 e to the power minus 3t. E to the power minus 3t. Okay. This is function of t, xt. Xt is the function of t here. This is 1 upon 2 in bracket 2 into c1 plus c2t e to the power minus 3t minus c2 e to the power minus 3t. Now putting here in above initial condition. Putting initial condition t equal to 0 here. If t is 0 here putting, then x0 is 0. So here x0, this equal to x means in our solution there is x. X means xt, not only x here. Here x t here, y t here. In our solution is xt and yt. So here x0 1 upon 2, here 2, putting t0 here. So c1 plus 0. Here e to the power 0 is 1 and minus c2 and this is also 1. E to the power 3t, this is 1 because e to the power 0 is 1. So we write here x0 is given here 0. 0 is 1 upon 2, here 2c1 minus c2. So 2 goes to this, 2c1 minus c2 is 0 here. This is equation 19. 2c1 minus c2 is 0. I am putting the initial condition in solution first. First means equation 18. This is 18 equation. Putting t equal to 0, then x0 is 0. So now again by solution. Yt is equal to, what is yt? Yt is c1 plus c2t. This equal to c1 plus c2t e to the power minus 3t. This is equation 14. Here putting t equal to 0, then y0 is 0. These are initial conditions given in our question. If t is 0, t is independent variable. T is 0, then function y. This is the value of t. T is 0. In our question, function t. Y is some function of t here. So t is 0. Y0 is given 0 here. So putting here y0, this equal to in bracket c1 plus c2. T is 0 putting here. E to the power minus 3t0. E to the power minus 3 into 0. E to the power 0. This is 1. This is 1. So writing here c1 and this 0 plus 0 and this into 1. So here is c1 and y0 is 0. So c1 is given 0 here. C1 is 0. And now last is this equation 20 and 19 equation. 2c1 minus c2 is 0. 2c1 minus c2 is 0. This equation 19. Putting here c1 0 here. So here 2c1, c1 is 0. Value of c1 is 0. So 2c1 0 minus c2 equal to 0 means 0 minus c2 equal to 0 means c2 equal to 0. So both constant are 0. So what is final value of our question after applying initially condition? So constant c1 and c2 putting in our question, then we get complete solution. Now x equal to xt. Xt is equal to what is value here? 1 upon 2. I am writing here value of x. X is minus 1 by 2. This x is 1 by 2 in bracket 2c1 plus c2 t e to the power minus 3t minus c2 e to the power minus 3t. This is the value of x. I have already find the value of x. This equation 18. Okay. Here putting c1 equal to 0 and c2 equal to 0. We have find the constant. Both constant are equal to 0. Then we find xt. Here t is not 0 putting. We putting the value of constant in our solution. So t is not putting here 0. So xt, we find final solution. 1 upon 2. Here putting c1 and c2 both are 0. And here c2 is also 0. So finally xt is 0 is 0. So xt is 0. Now y is equal to c1 plus c2t e to the power minus 3t. Putting here, again putting c1 is 0 and c2 is 0. This equation 14. In 14 solution, putting c1 and c2 is 0. So here is also y is equal to, this is 0, yt, this equal to 0. So this is the solution, final solution, xt is 0 and yt is 0. After apply initial conditions. Okay. So this is complete solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.